Okay. Let's go to the course. Okay. Let's go to the modules. Oh, before modules, can I have everyone's attention here? When you go on the syllabus, and let me say student view, and you do it with me, go to syllabus. Do you see link for worksheet 1 and link for worksheet 2? So by now you should be able to finish worksheet 1 by the end of today, half of worksheet 2. They're all due on Thursday. You click here and you submit the worksheet here. If there are 4 pages on the worksheet, you make it to one single PDF and turn it here. So worksheet is separate than My Math Lab homework. For My Math Lab homework, have your notebook, do it, and put your final answers. And that's it for My Math Lab. For this one, at the end of each module, there is a worksheet. So worksheet 1, worksheet 2. So once you do them, the answers are in the back as well. And I put some video answers to some of the questions. So then you go here, you show any part of your work that is possible. If it's definition, you say by definition, the answer is C. And normally is multiple choice. So you would say, they say determine whether it's experiment or observational. And then they write something. And then you would see, oh, did they modify or they observed? And then if that's observational, you say it's observational because they are not modifying or giving treatment. If it's experiment, you say it's experiment because they gave treatment. And then there are answers at the very end that you can compare your answers with. But I need some sort of work scene here. You can print the worksheet, or you can just write down the questions and say question 1, it's either experiment or observation, whatever is the answer, because we are just observing the result or we are giving treatment. And then going to the next and so forth. And once you're done, you make one PDF. So even if there are 4 pages, you making a PDF maker, you just make a PDF and submit it. Can we do it on a different piece of paper and submit that? Yes. So I'm just answering the chat. Yes, you can do it on a piece of paper, but you need to say which worksheet on top. Say worksheet chapter 1, and then say question 1, observation, for example, because we are observing the data and we are not modifying it. And then done, question 2. And then at the end, you compare the answers. Don't send me just A, B, C, D. I just want to know that you thought about it. And then you submit. If you're unsure about some of the things, then you can watch the video.
Oh dear, let's work on the worksheet.
Yeah, video is here. So it's not to every question, but to many of the questions.
Most of the questions on worksheet 1 are.
Do you see that? If you need help. Okay, so you have online homework on My Math Lab, which you need to check daily. The semester passes very, very quickly. And then you have a syllabus here, which shows you what's due. Normally, discussion boards, if we have any more of that, which we may not have much more, worksheets, and your work to quizzes and exams must be also, you put the final answer on My Math Lab and submit your work on Canvas. So quizzes, exams, and chapter problems are on Canvas. Homework is on My Math Lab. And then sometimes I put quizzes and exams on My Math Lab. You put the final answer there and you show your work and submit it here on Canvas. So just keep track of both. I try to explain it every time, but you don't know how many students are still Not sure where to submit it. So 2.1, it's PowerPoint for constructing frequency distribution. I need to change my device like maybe 5-10 minutes into the lesson today. And I hope my devices cooperate. I have one Surface here of my own for DVC and then my husband's tablet. I normally always teach with my Surface, but my Surface charger has issues as of starting yesterday. So I'm working to fix it. But yeah, I hope it works today. But be patient as I'm aware of the situation. I just need to work on it. So let's get it started and see where it takes us. So please open 2.1. Today's lesson is about exploring data with table and graphs. You have a bunch of data. You don't have any visual representation of that, just numbers. Putting it on a graph, putting it in a table. So if you have something like this, where the numbers are scattered everywhere, and then you want to put it into a table. So say from time this to this. So this problem is about lunch services at McDonald's. And then these are in second. They observed 50 customers. And then it took the first customer 107 seconds, like less than 2 minutes. The next one a little bit over 2 minutes. The next person a little bit over 3 minutes. The next person a little bit over, close to 4 minutes, and so forth. These are all in seconds. So you're not sure what is the average wait or lunch services at McDonald's by just seeing these numbers. So today we're gonna learn how to summarize our data into a table and then putting it on a histogram. So that's the goal of the day. And so by the end of the day, you should be able to do it. Let's just get started. So 2.1, 2.2 is our goal. And then 2.3, 2.4 for tomorrow. Okay. Key concept, we talked about it. We want to summarize, organize the data in a frequency table. Frequency distribution shows how data are partitioned among several categories or classes. And by listing the categories along with the numbers of data values in each of them. So we will categorize it or putting in classes, which we use the word classes more often. And then, but that's the same thing as category. And then that helps us to organize and summarize our data. Okay, definition, lower class, upper class limit, class boundaries, class midpoints, class width. So let's just see the words again. Lower class, I'm going to come back to this where you write the definitions, but let's just pay attention to the words. Lower class limits means there are multiple of them. Upper class limits, again, multiple of them when you're organizing the distribution. Class boundaries, again, multiple of them. Class midpoints, class width. So by the end of the lesson today, you have an idea of what these are. So if I go back to the table, whatever you see at the beginning, 75, 125, I'm going to tell you how you obtain them. 175, 225, 275. All of these called lower limits. 124, 174, 224, 274, 324, they call upper limits. So within each class. We're going to talk about class boundaries where you find the distance between 124, for example, and 125. 174 and 175. Between two classes, you want to know what is the boundary between 224 and 225. So basically going vertically and finding half of them. We also talk about midpoints, means finding half of each class by adding them and dividing them by 2. We'll do them as of example and writing it out. So a half of each table is just you add them, you divide it by 2, and that calls the midpoints. And then frequency is the number of times that you have, for example, 75 to 124. How many of these drive-thrus or how many of these lunch services were between 75 seconds to 124? And then we go to the table and we count the number of times that we see values between 75 to 124 and so forth. So that's the big goal. Let's just go back to the definitions. I want you to write down these definitions before we go to the table and start building it. Kylie, it's not attached to the worksheets are not attached to the assignments. The worksheets are at the end of each modules. So I can later attach it if you want, but it's at the end of each module. So it has its own category. Worksheet 1, worksheet 2. And write the class midpoints. I will clarify the class boundaries as I'm teaching. Yeah, we will work on the class boundary. Class boundary would be in the middle of each class, between the two classes. Okay. So a couple of things to mention here. Class width is each class, like within each line, you would see some length to the classes. To find the class width, if you have the number of classes, you go maximum value minus minimum value on the entire set and divide it by number of classes. If they say 5 classes, you divide by 5. If it's a 6 classes, 6. And you always round up the result to make it convenient. If it's already a good number, you keep it. If not, then you round it up, never down. So what does that mean? Let's go to this problem. So I want you to identify, and then please do these steps with me, because it's gonna, if we build one good histogram, first distribution table and then a histogram, then we might be able to produce many more of them. So it's easy to do it, but let's follow along. Tell me, what is the lowest value on the table? Do you agree 83? What is the highest value in the table? $308. Very good. I'm receiving your chats as we go along. Okay. So now in order to find the class, and then they say use 5 classes. They already told you how many classes. Sometimes they give you the class width. Sometimes they tell you the number of classes. So they gave you a number of classes. So number of classes means 1, 2, 3, 4, 5. Do you see you have 5 lines here? That's what they exactly mean by having 5 classes. So you have 5 lines. Okay. Now you want to find the class width. So remember, do you see 83 is the minimum, but they started from 75. Why? Because of what their convenience of a number. You could have a start from 83. You could have a start from 80. You could have a start from 75. You can start from any number you want. Do not navigate or go far from 83 much. You go always lower, not upper, because you need to include the lowest number in the set. But yeah, somewhere that is convenient. In this case, as they were setting this up, they felt that 75 is a good point to begin. Although again, you could have a start from 83, you could have a start from 85. So that part is more of whatever makes your distribution table nicer. Okay, so now let's find the class width. How do I find the class width? You go 308 minus, so you go the maximum value minus the minimum value. And then whatever that result is, you divide it by the number of classes. You have 5, 5. So please tell me what you get. 308 minus 83 divided by 5. Excellent, 45. So you have 45 here. You could use 45 as your class width, or you could go higher. I suggest, in this case, we rounded up to 50. Again, you could have keep it 45, 46, 47. So you could have keep it. For convenience of setting up the table, and then you can always round up. You go up by 5. You don't have to. You could keep 45. Okay. So beginning 75, again, for the convenience. Otherwise, you could have started from 83. Going from 75, I round up this value to 50. So I round it up. You always round up or keep it the same to 50. But it has to be a whole number anyways. If that was a decimal, you always needed to round up anyways. But I go to 50. you choose the first number, you make sure that is less than your minimum. Then you add the class width to get the number, next number. What is 75 plus 50? 125. What is 125 plus 50? So you first start with setting up the first values. Add another 50. And again, 50 is the class width. This is the class width. So, and then add another 50. If I add another 50 here to 275, then that would be 325. 325 is the beginning of something that is larger than my maximum. So I don't need the next class. So I stop right here. Then now I need to design my upper. So I'm going to use another color. So for the upper, you go one below the beginning of the next one. So 124. So you go basically, you think about it as of, oh, this is 125. I need to make sure I cover everything. And since they are whole numbers, I don't go 124.99 because even if I say 124, it's going to cover, these are whole numbers, so I don't need decimal. What is before 175? 174. What is before 225? 224, so forth. So that's how you design the upper. And you know, if there were a next class here, that would have been 325. So one before that is 324. Are we set so far? So we have the red ones are my lower class limit. And the yellow highlight is my upper level or upper limit, upper class limit. So now we want to design our frequency table. So we got the minimum and maximum of each class. We got the class width. Now, if you think about it, every class has the same width and they are exactly 50. 50 values in each category. So you always, I mean, you could have keep it as 45. Someone asked why 50. So you could have keep it as 45. They rounded up in this one just for the convenience. That's it. No other purposes. You could have been 46. You could have used 47. It should be a number larger than 45 or larger. Yes, you could have keep 45. And then the table is not unique. Your distribution table might be different than mine. It's important that you be able to complete it as you work, because our tables may look different, but it's important that the class widths to be the same for each class of your own. So it means adding 50, if you're adding 46, add 46 to all of them. If you're adding 45, add 45 to all of them. You could have begun from 80 instead of 75. Then whatever you are doing, it needs to be consistent within your own table, if that makes sense. Okay. As long as the class width is consistent. And then Eli said, so the idea is just to offer some sort of range in frequency for each class. Yeah, for each class, you need to have a class width. But then that class width has a minimum of 45. But you don't want to go from 45 to 100. You just pick a number that is convenient within some distance. There is no exact contract there, but yeah, you could have keep it as 45. Okay, so now let's go through the table and then count the numbers. So, oops. So let's count the numbers. How many numbers do I have between 75 and 124? Yeah, that's 1. Until 124. 124, 2, 3, and you can cross them out. 4, 5, 6, 7, 8, 9, 10, until 124. Which one did I miss? I'm sure you guys got it. Oh, 83. Yes, you're right. 11. So that's why it's 11 numbers in the frequency. And so forth. You go, how many between 125, including 125 and 174, and so forth. So if you add the frequency, what do you think you should get? What should be the total? You're counting the numbers and you're crossing them out and writing math. So how many data you have and what would be the total frequency? So add the frequency and tell me what you get. Yes, 50. And that's exactly the same. So that's the total. So that's exactly the same as the number of people you observed, because you need to fit all of them in the table. So that's why if you add the frequency, it's the same thing as the number of data you had. Now let's talk about relative frequency. So let's see what is relative frequency. Relative frequency is a decimal or percentage. And the way to find it, and the way to find relative frequency is the way to write the relative frequency is this is how you calculate it. You go partial, the partial is 11 within each class, so relative frequency and that would be partial, that's 11 over total, that is 50. Put it to your calculator and tell me what you get. 0.22, that's great. In order to find the percentage here, what do? 0.22 is 22%. So what I want you to do is I want you to find the rest of relative frequency by saying each number divided by 50, find the decimal, that's the frequency, and then to find the relative frequency, and to find the percentage, you multiply by 100. So do that. In the meantime, I will log in with my tablet, not my own. My own doesn't work any longer. So my husband's tablet. So I hope you have the PowerPoint in front of you to find the relative frequency until I log in. This code to enter here. Okay, I need great. I'm seeing you're sending answers. So let me stop sharing here and log in with my other device.
Recording in progress.
So, do you hear me now? Yes. Okay, great. So now, from this point on, because I need a whiteboard and I want to just draw, so I'm using another device. Okay, so now you have the table. For the table, I'm going to redraw the table here. So the values between 75 to 124, 125 to 174. I'm just copying it down. That's for time in seconds. 175. I didn't write time in seconds, but you all know that. It's in front of you, hopefully, on that PowerPoint. To 224, 225, all the way to 274, 275, all the way to 324. Okay. And then we got the frequency. This was time in second. We got the frequency 11, 24, 10, 3 and 2. And then you got the relative frequency. So you got the relative frequency to be 0.22, 0.48, which is 22%. You multiply by 100, 48%. Was it 0.2? So 20%, 0.066%, and then 0.044%. Do we all have that? Any questions so far? That's the relative frequency. What I want to do in the next step is showing you, if this was given, I could have found the class width by subtracting the two consecutive lower limits, 125 minus 75, 50. I knew the class width is 50. So it means there are 50 numbers in each class. So 75, 76, 77, 78, so forth. So that's the class width. So if I was asking for class width, I would have subtract any two consecutive lower limit, and then that would have given me the class width. Doesn't matter which two consecutive ones. So that's one thing. Okay. So now the next. Okay, 75. There we go. So that was class width. lower limit, upper limit, we know that the beginnings are lower limit of each class. The ending are upper limits of each class. And then we know class width. Now let's talk about class boundaries. Class boundaries. To find class boundaries, again, there are multiple of them. So you would say, you would take the upper limit. So pay attention to this. You get upper limit of one class with the lower of the next. You add them. And you divide it by 2. So that's 124.5. Do you see that? That's the first class boundary. The next class boundary, same thing. You take the upper and the lower. You add them, 174 and 175, and you divide it by 2. Every time to find the class boundary, you add the 2, you divide it by 2. 174.5. So keep going. It's going to be 224.5, 275, 274.5. And then, so one important thing, if there was a class before this, the ending would have been 74. So the very beginning class boundary is addition of 74 and 75, and that would have been 74.5. If there was a class after this one, would have a start from 325. So to find the class boundary here, you add 324, 325 divided by 2 is going to be 324.5. That's how you find all the class boundaries. Makes sense or not? The last part, you mean the class boundaries of before and after? So 75 is the ending. So every time to find the class boundary, look at the green circles. 124, add to the beginning of the next class, that's 125. You add them, you divide it by 2. Then end of this class, beginning of next class, you add them, you divide it by 2. For everyone, end of the one class, beginning of the next class, add them, divided by 2. Do you get that, Jennifer? And then if there was a class after, then that would have been 325, 324, 325, add, divided by 2. Yes?
So even the very last number, like 324 and 325, like we calculate that class boundary as well?
Yes, because in the graph of histogram, that's going to be the last number. We also need to calculate the number before, because that's going to be our beginning number. So beginning number is 74.5. In graph of histograms, we use class boundaries.
Okay, thank you.
And class boundaries is halfway between the two classes. So that's why you add them and you divide it by 2 always.
Got it. Thank you so much.
You're welcome. So that's class boundaries. So send me a chat and say if you understood class width so far by subtracting 2 consecutive, or the way we divide it, and class boundaries. So just say yes, no's, I need more help, something that I know where we are. Class boundaries, yes or no? Okay, great. I'm not always looking for yeses. I'm always looking for your honest reply so I know what to do. So class width, someone asked if I can explain class width again. Class width, you can find it by subtracting max minus min and divide it by number of classes. In this case was 5. Either keep it or round it up. Keep it or round it up to the convenience number you have. That's where you have the class number. If you have the table itself, and then you write the minimum number and you add the class width, in this case was 50 to get the next one. Add 50 to get the next one. Add 50 to get the next one. If you don't know what is the class width and the table is given, basically the difference of two consecutive lower, like 125 minus 75. What is 125 minus 75? 50. 175 minus 125, 50. 225 minus 175, 50. So the subtraction of two consecutive lower level or lower limit will give us the class width. Any other questions? Let me see if I covered.
I have a quick question.
Uh-huh.
Usually when we see problems, are we given like a table like that, or sometimes do we have to create because I remember you saying like we could get to create our own like lowest number, like 75. It doesn't
Yes.
need to be 83.
Yes, sometimes you need to create your own. Sometimes the beginning is given. If the beginning is given, then all of us will have the same answer. If the beginning, if that's not given, then our answers may vary. So it's not unique.
And then if we were to create our own table, then the class width, we get to determine it. We just have to make it consistent all the way across, right, for the class?
Yeah, or just, you create your own class width. Someone might pick 50, someone might pick 51, someone may pick 46. But to be right, you need to pick 45 or higher. So anything that is within that, I will give you grade you desire.
Thank you.
Okay, you're welcome. So now I'm gonna erase the boundaries I wrote. Just you have them written out because we will be using them for histogram soon. Whiteboard is limited compared to what I have on my Surface, but okay. So one more thing before I go to histogram is if I ask you for class midpoints, to find class midpoints, again, these are all definition. No one was born honestly knowing what is class midpoint, what is upper, what is lower level or lower class, what is class boundaries. You got to practice it. So there's no other way around it. And again, whoever knows it, that's because they studied it. So keep it that way and don't panic with a lot of vocabulary here. Just summarize it, write the formulas, put dedication and heart into your studying. And then, having them all in a very organized note. So to find the class midpoints, you add the lower and upper of each class and you divide it by 2. So 75 plus 124 divided by 2, that's going to give the midpoints. So 75 plus 124 is 199. Divided by 2 is, I think, 99.5. So you add them, you divide it by 2. So that means this number, 99.5, is in the middle of this set. So I see someone was sending me a number like 24. Sabika, that's okay to have 24 plus 5, but remember you need to add that to 75 to get the midpoint. So you could have subtract and divide by 2, but then you need to add to the beginning. And that's where you get 99.5. But be mindful of what you're doing. Okay. And then the next midpoint would be, that's midpoint, not class boundary, 125 plus 174 divided by 2. So do it, I think you're gonna get 149.5. So do the math for me. So that number should be halfway between these two numbers. Did you get 149.5? Confirm, please. I want you to do it with me because I know how to do them. I want you to also practice it. Okay, great. So now let's go to the graphing histogram. So that would be, so let's just start with the class boundaries. 74.5. So we have 1, 2, 3, 4, 5, 6 class boundaries we have. 1, 2, 3, 4, 5. Let me just put it more distance. So 1, 2, 3, 4, 5, 6. This is nicer. The class width, the distance of the bars must be the same. The next one is 124.5. These are all class boundaries. 174.5, 224.5, 274.5, and the last one was 324.5. The horizontal is the class boundary. So all the boundaries here. The class width are the same for all of them. If you subtract them, you get 50, 50, 50, 50 for all of them. The vertical axis, it's going to be the number line. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excuse my axis here. So it's going to be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Because I have 24, it's going to my table, but you know what I'm doing. Okay, let's just start with the first one. For the first class between the two boundaries here from 74.5 to 124.5, I have 11. So I go 11 up. And that's the first bar. It should be no distance between one bar to the next unless there is a 0 on the counts. So the next one, it's 24. So you go up all the way to 24. So that's there. Sorry, again, that goes to the table. 174.5 to 224.5 is 10 of them. So I go up 10. So a little bit lower than 11. Okay, the next one is 3. And the one after that is 2. So compare what you have now in the table, knowing where the distribution is. Look at the histogram and see what you have on the histogram. So you see a lot of data are within the center, are means that many of the orders or lunch services takes between 124.5 seconds, about 2 minutes, to a little bit less than 4 minutes, to 24 seconds. So somewhere between 2 to 4 minutes, or that many seconds. Majority of data falls in here. So that's like a center of our set. So this is much nicer than that table that you had numbers scattered everywhere. And that's what we mean by organizing and summarizing the data. So that's the table and that's the histogram. We will be seeing another example in a video. But before that, do you have any question here? No. Okay, so I'm gonna quit this one and go to my laptop to show you some more on the PowerPoints. And then if you have time, we're gonna watch a video that I posted. Okay, let me quit sharing. Stop sharing here. Okay, from here. So now let's go and continue our problem here. So I'm gonna go on the PowerPoint. So here we go, just explanation of what we did, how we got lowers first, and then based on the lowers, we got the previous to find the uppers, how we got the frequency by partial over total, and we multiplied by 100% to get the percent. So, and there should not be gaps. So that's why we use class boundaries. If the table has decimals, so if that's a 2 decimal, so this is just the frequency of a table with decimal and with gaps. So I tell you that if you have 2.4, let's say the class width. Oh, can you tell me what is the class width? Just observe this one. Let me ask a couple of questions. Tell me what is the class width? Use your calculator. Tell me what is the class width? You are fabulous. That's right. 0.1. Excellent. You just subtract 2 consecutive numbers and then lowers, and then that gives you class width. Tell me, give me example of 1 or 2 of the lower class limit. So I just want you to identify some of the lower limits. I don't want you to give me the whole list. Maybe the first 2. Lower limit. Excellent. Excellent. So numbers are coming. Yes, 2.4, 2.5, 2.7, 2.8, 2.9, so forth. Grab your calculator. Between the first class and second class, give me the class boundary. That requires a calculator, and send it to me through chat. Grab your calculator. That could be even your phone calculator. I'm still waiting to receive more. Very good. I'm getting. Tommy, think about it more, because as you're adding the upper and lower and then dividing by 2. Excellent. Very good, everyone. So you add 2.49 and 2.5 and divide it by 2. Excellent. So you don't round the values for the class boundaries. You don't round the class boundaries. That's the thing. Okay, unless it's directed otherwise. Okay, so that's good. So you got the class boundaries, and you can, the same way, this would have been 2.39, then you could have find the class boundary there. Do you see that there are 0 pennies waiting this much? So they have 0, 0, 0. That's gonna be where you see the gaps. Okay. So I just wanted you to be familiar with decimals as well. So look at here, sometimes we used frequency table and graphs to compare. So in this case, the time, the lunch services, they are comparing lunch services as at McDonald's versus Dunkin' Donuts. And then I want you to observe. So you're comparing the two. This is the frequency of 22%, for example, of lunch services falls between 75 seconds to 124 and so forth. And then for Dunkin' Donut, 22% of time happens here and then so forth. So tell me which one has a faster service between McDonald's and Dunkin' Donut, looking at the table, and then why? If you can explain it to otherwise, just which one has a faster service. Great. Great. Do you see the shift? So it seems that everything, it's one step faster, and then 6% of the time falls in 175 to 224, which is, you know, somewhere like about 4 minutes, between 3 to 4 minutes. Most of them are happening before 3 minutes, where McDonald's is slightly higher in time. Exactly. Awesome. Okay, so that's for the frequency table. As Azia answered, Dunkin' Donut is faster. So what I want you to do is now log in to Canvas again and go to let me share my screen again. Go to 2.2. 2.2 is just the histogram. We already did it. We are just reviewing, paging it together. So let's go to modules. Let's go to 2.2. Histograms. Okay, here's the key concepts and forward. It's very useful for summarizing data, as you already seen. Even better to as a histogram, so then you can easily see, visualize the number on the graph. So a couple of things on the histogram. A graph is consisting of bars of equal width. We are all agree with that. Adjacent to each other, no gap unless there is no data. For the zeros, it's like your vertical movement is just zero, is a straight line. Horizontal scales represents classes, boundaries for us, but it could be, you're gonna see a video that it could be just writing the numbers. In our classes, class boundaries mainly. The heights of the bar corresponds to the frequency values. So if when the frequency was 11, we were going up 11. When we were going 24, 24. So the vertical ones is based on the frequency. So the visual distribution of the shape is important. So either it's very central and like it looks like a bell. We call it bell shape. We call it normal distribution. Or it could be skewed to left or right. Or it could be all equal bars. We call it uniform. I'm going to go to the page where you see all different cases of shapes. So I'm going to go there soon. Shows the center where most of values falls. With the McDonald, we said, oh, most of values seems to be between 124, for example, to I think was 224.5. So wherever you see most of values falling, so that's the center. Spread means where is the beginning, where is the end of the data? Where is that spreading from where to where? And then outliers are the numbers that are way off of your graph. So if you had one of the lunch services, if that was like taking 10 minutes, 600 seconds, 500 seconds, that would have been way off of the rest of the data. That we call that outlier. So here is the graph. We already seen that. So this one is, we call it a skewed. Some may say, oh, this seems to me to be roughly symmetric, but it seems that it's a skewed where you see tail on the right. Do you see tail on the right? If you were just graphing a bell over this one. So let me just show you what I mean. So if I was drawing, so look at this one. If I was drawing a bell, do you see that I had a tail here? This tail is on the right. So if the tail is on the right, we say right skewed graph. Center of the data, most of values are here. And the values are going between 74 to 324. So within that distance. Okay. Center of the data where most of values are. Variation, where is beginning, where is that ending? We work a lot on center and variation in chapter 3. Shape of the distribution and outliers. So shape of the distribution. I want to give you 2 minutes. I want you to copy this. Where do you see this is bell-shaped? We call it normal distribution. Almost equal bars, we call it uniform distribution. If the tail is on the right, we say skewed to the right or right is skewed. If the tail is on the left, we call it a skewed to the left or left is skewed. So wherever is the tail, we call that to be right or left. So right is skewed. So I want you to copy this down. Okay. So I have these handy in your notebooks. Well, again, normal distribution looks like a bell shape. And then a skewed could be in any side. It's not symmetric. Skewed to right, skewed to left, depending to where the tail is. So for normal distribution, they also described it with straight line, where normal distribution, if the points are close when you put the scatter plot, if it's close to a straight line, it's a normal distribution. But then these points should not have any pattern. So I'm not asking you assessing normality with scatter plot, but just to see. This is not close to a line, so it's not normal distribution. And this one is close to a line, but since it has a pattern, is not a normal distribution. The way that I ask you in this class, I give you that it's assuming that it's normal distribution, or you just look by looking at the graph, histogram or bell shape of if there are any other kind of graph too, looking at the bell shape. So normal, skewed, skewed. When the tail is on the left, left is skewed. When tail is on the right, right is skewed. Okay. So let's just do something for before the ending. So let's go to modules. At the end of 2.2, I put a video, so I want to play that video. It's just, I think, 5-6 minutes. That's another way of, or just a sort of short way of graphing histogram, which I want you to get general idea. We did it in details. So this is more of giving you a quick general view of graphing. And he graphs it with just putting the class itself from minimum to maximum. So just know that that way also exists. Maybe in most of homework, I want you to do it with the boundaries that I did. But let's look at this one. And tell me if you hear it.
So let's say you were to go to a restaurant and just out of
Do you hear it?
curiosity, you want to see what the makeup of the ages at the restaurant are. So you go around the restaurant and you write down everyone's
good.
age.
So let's just get
And
us
just out
started.
of curiosity, you want to see what the makeup of the ages at the restaurant are. So you go around the restaurant and you write down everyone's age. And so these are the ages of everyone in the restaurant at that moment. And so you're interested in somehow presenting this, somehow visualizing the distribution of the ages, because you want to just say, well, are there more young people? Are there more teenagers? Are there more middle-aged people? Are there more seniors here? And so when you just look at these numbers, it really doesn't give you a good sense of it. It's just a bunch of numbers. And so how could you do that? Well, one way to think about it is to put these ages into different buckets and then to think about how many people are there in each of those buckets, or sometimes someone might say how many in each of those bins. So let's do that. So let's do buckets or categories. So I like, sometimes it's called a bin. So the bucket, I like to think of it more of as a bucket. The bucket and then the number in the bucket. The number in the bucket. Number, I'll just write the number. Whoops. It's the number. It's the number in the bucket. All right. So let's just make buckets. Let's make them 10-year ranges. So let's say the first one is ages 0 to 9. So how many people, and let me just define all of the buckets here. So the next one is ages 10 to 19, then 20 to 29, then 30 to 39, and 40 to 49, 50 to 59. Make sure you can read that properly. And then you have 60 to 69. And I think that covers everyone. I don't see anyone 70 years old or older here. So then how many people fall into the 0 to 9-year-old bucket? Well, it's going to be 1, 2, 3, 4, 5, 6 people fall into that bucket. How many people fall into the 10 to 19-year-old bucket? Well, let's see. 1, 2, 3. 3 people. And I think you see where this is going. What about 20 to 29? That's 1, 2, 3, 4, 5 people. 5 people fall into that bucket. All right. What about 30 to 39? We have 1, and that's it. Only one person in that 30 to 39 bin or bucket or category. All right. What about 40 to 49? We have 1, 2 people. 2 people are in that bucket. And then 50 to 59. So you have 1, 2 people. 2 people. And then finally, ages 60 to 69, a different color, 60 to 69, there is 1 person right over there. So this is one way of thinking about how the ages are distributed, but let's actually make a visualization of this. And the visualization that we're going to create, this is called a histogram. Histogram. We're taking data that can take on a whole bunch of different values. We're putting them into categories, and we're going to plot how many folks are in each category. How big are each of those? How big are each of those categories? And actually, I wrote histogram. I wrote histograph. I should have written histogram. So a histogram. So let's do this. All right. So on this axis, let's see. The largest category has 6. So this is the number of folks, and it's going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the number. And on this axis, I'm going to make the buckets. The buckets. And let me scroll up a little bit now that I have my data here. I don't have to look at my data set again. So I have 1 bucket. This is going to be the 0 to 9 bucket right over here. 0 to 9. Then I'm going to have the 3. Actually, let me just plot them since I have my pen that color. So in 0 to 9, there are 6 people. 0 to 9, there are 6 people. So I'll just plot it like that. And then we have the 10 to 19. There are 3 people. So 10 to 19, there are 3 people. So I'll do a bar like this. Then 20 to 29, I have 5 people. 20 to 29, which is going to be this one. It's getting, I'm writing too big. So 20 to 29, this is going to be this bar. There's 5 people. 5 people. 60 to 69, we have 1 person. 60 to 69, we have 1 person. We have 1 person. And what I have just constructed, I took our data, I put it into buckets that are kind of representative of the categories I care about. 0 to 9 is kind of young kids. 10 to 19, I guess you could call them adolescents or roughly teenagers, although obviously if you're 10, you're not quite a teenager yet. And then all the different age groups. And then when I counted the number in each bucket and I plotted it, now I can visually get a sense of how are the ages distributed in this restaurant. This must be some type of a restaurant that gives away toys or something, because there's a lot of younger people. Maybe it's very family friendly. So every adult that comes in, maybe there's a lot of young adults with kids and or maybe grandparents up here, and they just bring a lot of kids to this restaurant. So it gives you a view of what's going on here. Just a lot of kids here, a lot fewer senior citizens. So once again, this is just a way of visualizing things. We took a lot of data that can take multiple data points. Instead of plotting each data point like we might do in a dot plot, instead of saying how many 1-year-olds are there, well, there's only 1 1-year-old. How many 3-year-olds are there? There's only 1 3-year-old. That wouldn't give us much information. We would just have like these single dots if we were doing a dot plot. But as a histogram, we're able to put them into buckets. And we're just like, hey, generally between ages 0 and 9, we have 6 people. And so you see that plotted out just like that. And obviously this doesn't apply just to ages of people in a restaurant. It applies to all sorts of data that you might want to collect and observe. So let's say you were to go to a restaurant and just out of curiosity, you.
Okay. So that's for that part. A couple of things to mention here. Again, under syllabus, you should be able now to do chapter 1 completely. And the way you find the chapter worksheets, at the end of each module, there is one section that says chapter worksheet. And then I tell you which problem. If I say do all, you do all. Sometimes I eliminate some. There are short videos. Same thing with the second one, with module 2. There is a worksheet. You can get us started on that. So and this one say do all, and then there is a video if you need help. So when you're seeing the answer for chapter 2 worksheet, there is a 1 round up for, because I put the PDF, I think the solution for this one, I was putting as a written answers. So here, I think when you divide it, you get 8 point something, not 9.2 something, but you can always round it up to 10. So I tell you that they have a typo here, but it's okay to keep it as 10 class width. Although this is going to be 8.25, but it's still, as we learned today, it's okay to round up to your comfortable rounding. So one thing, another thing is My Math Lab. Sure, Ayush, I got that. So let's go to My Math Lab. And then in My Math Lab, let me share my Math Lab. Okay. Go to Pearson. So your homework for these days until the exam is there. So when you go to assignments, you see everything listed. So you just click on them. And by now you should be able to do 1, 2, 1, 3, already 1 past due. But you read the questions, it's still multiple choice because a lot of definitions. But then on the list of homework, 1 is past due, that's done. If you did it, not did it, so it's over. So 1, 2, 1, 3, you could do it. I gave you until tomorrow night, but you remember I said we are meeting half of the time. So I suggest that you spend time on doing these after class because that's sort of that I sort of incorporated that into the course as of you spend some time after each class. Although the deadline is 17, but I would say just do it today. So then tomorrow when I teach 2, 3 and 2, 4, you finish them. So you don't wait until the 20th to finish those. So this way, exam that is coming up on Monday, you have time to study. After today, I will post a quiz that is also like a practice exam. And then on Monday, you have exam 1. So again, not that I love spending all my summer days grading, but I put a lot of exams because I believe that you have shorter number of sections or chapters to study. And then if you mess up with one, then your average will not be, a lot affected. So you still have time for improvement. If I was putting 2 exams, and if you would have not do well on one, plus that you have many sections, then you would not be able to make up or basically improve. Not that I give you a chance of make up the exam, but then you work hard and sort of by getting a higher grader on the following exams, you make up for the percentages that you lost. Okay, any other questions just to be sure? 3 homework on My Math Lab. Yeah, 1 worksheet. Yeah, by the end of tomorrow or tomorrow night, you have 2 worksheets on My Math Lab. The quiz, I'm going to put the quiz up tomorrow, but you have until Sunday night to do it. And the exam is on Monday. They are both on cam. And they're going to be both on My Math Lab. For quiz and exam, you show your work for every single question and you submit your work on Canvas. So I'll show you how. So I put a link on Canvas that after you finish the quiz on My Math Lab, then you submit the work that you did. Do we have only 1 try? No, for the quiz, you have 2 tries. For the exam, you have 1 try. Quiz is more of a practice as well. So I put 2 tries so then you can improve yourself. But exam is just to test you. Did I answer everyone's question? So if you have My Math Lab that are just homework, you do them, you keep the work to yourself. We have quizzes and exams, you do them on My Math Lab, and then you submit your work on Canvas, and then also put your final answer on My Math Lab. And then we have worksheets that are at the end of each chapter. How long is the exam? You mean time-wise? 2 hours. How many questions? I don't know. Equivalent of something that can be done in about 90 minutes, but for that one, maybe partial of that on the Zoom, and then I give you the rest to finish it. Or sometimes I say, like, I put it up, and then I say you have until 11:59 p.m. of tonight to finish it. Once you open it, you have 2 hours to finish it. So this exam that is coming up on Monday, I may just open it. Maybe we need all to come to class for a couple of, for the beginning, I check IDs, videos, and then you finish it on your own. If that makes sense. Okay. If anyone wants to talk to me, then I will be here. Okay, have a great time. So stay here if you have questions for me.
Thank you.